Here you see sex chromosomal aneuploidy in newborn survey, not in the abortion. In abortion, the number would be very different and very, very bigger than this. When there is sex chromosomal abnormality, when they are alive, we did the analysis and this is the answer. Sex chromosomal abnormality is much more in the male. 1 in 360 male birth. For the lady, it will be 1 in 580. Means 2 times more, nearly 2 times more in male than in the female. Klinefelter, 1 in 1000. Extra Y, 1 in 1000. Other X or Y aneuploidy in male will be 1 in 1350. For the female, Turner would be 1 in 4000. Triple X in 1 in 900. Other X aneuploidy would be 1 in 2700. You shouldn't remember these numbers, but you should know which one is much more common or which one is less common. I will ask you this way. Remember, autosomal chromosomal abnormality can be diagnosed at birth because the sign and symptom is quite clear. But sex chromosomal abnormality is not easy to find out up to the puberty, because there is something wrong on the puberty, then we will find it out by doing karyotyping. There is one exception, Turner syndrome. Turner syndrome has got enough sign and symptom to be found out at birth. Others, not easy to find. It depends on the doctor and how he do examination to find that out or not. You will see what I'm telling you now. 50 years ago, we realized Y chromosome is crucial for male development. Crucial means necessary, but not enough. Maybe we have Y chromosome, but some part of Y chromosome is vanished. Again, it is XY but female. So Y chromosome is crucial for male development, but not enough. We will tell you why. 50 years ago, we realized Y chromosome is very important to be a male. In the Y chromosome, we have in the PR and QR, we have pseudo-autosomal region. Means, of course, they are on the sex chromosome, but seems to be autosomal behavior. Why? Because we have recombination. We have pairing and we have recombination. Because of that, you can see, for example, 3 or 4 boys from the same father, but one of them is tall, one of them is short, one of them is very high IQ, other one is low IQ. Why this happen? Because pairing and recombination is by mistake doing something wrong. X and Y chromosome are still actually distinct, but it seems they had common progenitor. Y chromosome lost many of its genes, remain only 50 genes. Because of that, in some papers you can read the Y chromosome is decreasing or is vanishing or something like that. There are ladies behind this kind of paper saying that the Y chromosome is gone. But we don't ask this for the female. They are fine, but somehow they are writing paper like that, which is not good ones. We have 50 genes in Y chromosome, and the ladies has got 2 X chromosomes, but one of them is inactivated. I'm telling, if there was much more genes on Y chromosome, or both X chromosome of ladies are active, we are very different from each other. But the difference is not too much. The difference is on the hormones, the difference is on the external genitalia. Female has got ovary, male has got prostate, something like that. The difference is not too much, because only 50 genes on Y chromosome and X is inactivated. The pseudo-autosomal region means we have some places in X and Y chromosome. They do same as autosomal chromosome. They do pairing, they do meiotic recombination, and it results in the variation between males or variation between females. So this autosomal region between an X and Y can be recombinated. It is physiologic, it is the beauty of God, it is a miracle of God. We said only 50 gene is important in the Y chromosome. One of them is SRY, a specific region in Y chromosome. Maybe it is a male, he has got Y chromosome, but because this SRY region is deleted, it should be female. A specific region in Y chromosome is very important. What about the others? DAS gene, deleted in azoospermia. If there is deletion in this part, of course it is male, of course it has got Y chromosome, but the semen analysis show 0 sperm. No. The genitalia is male in this one, but there is no sperm in the semen analysis. From the time of conception, if the sperm is X, it would be female. If the sperm is Y chromosome, it would be male. So the male is responsible for sex determination. Somehow, some man in some countries, they are punishing the lady. Why do you have too much daughter? There is no boy. I wanted to have a boy. You are the problem, not the lady. The Y chromosome is there. So the time of conception, he says, yes, I know I am the problem, but I am the powerful man. I am the king of house. So I decide to punish him. So by the time of conception, the sex would be selected. But up to 6 weeks, the development of gonad would be bipotential. Up to 6 weeks, the gonads are not differentiated to go for male or female. Of course, X and Y is there. We will go for paramesonephric duct. When the Y chromosome is absent, we will go for ovary and external genitalia of female. We go for mesonephric duct. When the Y chromosome is present, SRY region is present, then we will go for testis. Then we have androgen, it would be male external genitalia. So this means if a lady who do exercise and she do exercise, she eat androgen to have much more muscles, the problem would be the baby would be male external genitalia. Even the Y X chromosome is there is no Y chromosome. So it means androgen external or estrogen progesterone external may result in a problem in the baby. Another gene, SRY region or TDF, testis determining factor. Of course, it's not another gene, another name for the same gene. If the Y chromosome is there, but this part is deleted, again, external genitalia would be female, not male. So these are very important places for going for external genitalia, male or female.
What caused the deletion of SRY?
We don't know. There is a lot we don't know. Why it's happening in that specific person, not in the others. Same question for the trisomy 21. We say it's 1 in 800. Why 799 lady has got normal baby, only this lady has got abnormal baby? We don't know. Maybe a trace element, maybe an stress, maybe hormones, maybe something we don't know yet.
Is there any relation between eating meat and SRY deletion?
No. It's not a usual one. Let's go for having meat. He's asking meat and deletion or no. Not this usual thing shouldn't be the case. Otherwise, the vegetarian should go all for ladies. Wow, this is not happening. They are the people who are eating only veg. This is not the case. So, very important issue. We don't know a lot regarding sex physiology, regarding male or female, and how some people are abnormal, how people are normal. It is very unclear data. We should find out in the future. Several factors important. SRY region is absent, it would be female. Present, it would be male. Hormones, estrogen, progesterone go for female. Androgen go for male. In some people, even we have enough estrogen, progesterone, androgen, but the problem would be mutation in receptor. Again, it would be resulting in sex reversal. Do we have testosterone enough, dehydroxytestosterone enough? It would be male. Not enough, again it would be female. And one important issue would be anti-Mullerian hormone. Is it quite high? It would be male. And usually in infertility of ladies, we check for that one. Maybe there is a problem in the too much androgen, anti-Mullerian hormone. It results in the infertility of the ladies. So these are very important issues. Alhamdulillah, we are fine. DAS gene, written azoospermia. Also, we have 3 class of genes, AZF, A, B, and C. If they are there, everything is fine. One of them is deleted, the result would be azoospermia per se. The external genitalia is there, sex is normal, but there is no sperm, and it would be 0. The semen is there, but the sperm would be 0. Why? Because we have deletion in these 3 class of the genes.
What is the AZFB?
AZF factor, azoospermia factor, A and B and C is 3 class of on the Y chromosome. A, B, C means different places. Several genes can result on the having normal sperm. So, here is the sex chromosomal abnormality, 4 different columns. First column, Klinefelter. Karyotype would be XXY. This second X is inactivated. Some Klinefelter patient has got XXXY. Again, this 2X would be inactivated, but whenever the number of chromosome is much higher, the symptom would be severe, even we have inactivation. The phenotype would be male. They have atrophic testis. When you have the baby, you will check out is there the testis is in the place or not. If there is no testis at all, then we check for the Klinefelter. They are not fertile, usually not fertile. IQ is normal, behavioral problem may happen somehow. They have a hypogonadal feature. In the next slide, you will see how is the hypogonadal feature. Extra Y, another Y. This 2Y is active. In the male, we don't have Y inactivation. Usually normal, they have fertility. They are tall. They have severe acne. Extra Y, previously they said they are antisocial. Then they checked, they said no, that there was a mistake because we did sampling on the prison. In the prison they are antisocial, they are crime, and maybe there would be a little bit much higher extra Y there, but it's not the case for everyone. When there is a boy, tall boy with severe acne, you can do karyotyping and you can see extra Y is there. In lady, we have Turner 45X. They have a strict ovary. If a lady is short stature, if a lady doesn't have menstruation, we name it as primary amenorrhea, we will ask them to go for sonography of abdomen. In them, we find out a strict gonad or maybe no gonad. The sonographist write it down, I haven't seen any gonad. It means there is Turner syndrome. Let's go for karyotyping. Is it mosaic? Is it full monosomy of chromosome X? Then you can say how we should go further. They are short, they are neck webbing and aortic coarctation, which can be seen again by echocardiography. Triple X, 2 of these X would be inactive. They are female, external genitalia is fine, they are tall. Usually, they are fertile again. Extra Y. and triple X, they are fertile, otherwise they are not fertile.
If we have XRY, we cause it to be tall.
Sorry?
I mean, he have a tall because he have XRY.
Yes, yeah, they are tall because they have X and Y. Means there are some genes on the Y chromosome responsible for height. There are some genes on the X chromosome responsible for being tall. Less that, it will be short.
And the first case, the filter is absent of
Testis.
the AZ gene is absent.
No, the AZ gene is there. We have XXY because of the 2 copy of chromosome X. We have the disorder. The AZ gene deletion is not the case. No, you will see that. Be a little bit patient. Turner syndrome, 1 in 4,000 means if we try to help 4,000 lady to have a girl baby, 1 out of them would be Turner syndrome. Survival to term is rare, means 99% of this baby would be aborted. This is the highest number of abortion we have in the chromosomal abnormality. 99% for Turner syndrome, 75% for Down syndrome, 95% for Edwards syndrome. You should remember this kind of numbers, which is very important. 50% of them are full monosomy, 25% of them are mosaic. In these mosaic ones, the symptom is very low. It's not easy to find out. Up to the higher age, when there is no baby out of this family, then we check that, then we say, okay, the problem is she has Turner syndrome, the feature is fine, phenotype is fine, but having ovum out of this lady is not an easy job. Usually caused by paternal error in meiosis. Means this lady has the ovum with X chromosome, but not X chromosome from the father. They are tall, they are short stature, they are web neck, they have lymphedema in hand and feet. I said the only sex chromosomal abnormality at birth you can see the sign and symptom is Turner syndrome. Lymphedema in hand and feet, short stature plus web neck of the neck, web neck. Okay? Short stature, gonadal dysgenesis or steric gonad in the sonography of abdomen, infertile, web neck and broad chest. The chest would be broader than usual, elevated frequency of renal or cardiac abnormality. Means when you realize there is a lady with Turner syndrome, of course you should do karyotyping, of course you should go for echocardiography to check for heart, of course you should do sonography for kidney to see is there anything wrong on the kidney or not. I said usually it is paternal side, means if the X is derived from the mother, which means paternal X is lost, the patient tend to have significantly worse social cognition skills. Means the lady, normal ones, has got 2X, one of them is inactivated. But X from the father or X from the mother, it results in the behavioral genetic problems. Means there are a lot we don't know what's happening in this one, why this happened. But remember, when we say X inactivation, means all the X more than one would be inactivated. This inactivation happened from the time of conception, but it can change from mother to the baby. For example, I wanted to show some person. If this lady is X inactivation from father, but she will have ovum, maybe the ovum out of this mother, X inactivation come from the mother. It can be changed from the ovum to ovum. So it is very interesting to know that. But X from father or X from mother can be differentiated from each other. IQ is normal. This means nobody can go for a screening of sex chromosomal abnormality to go offering abortion. We can't go for that. The Klinefelter, the Turner syndrome, triple X, extra Y, all of them should go for finalizing the pregnancy. Nobody can say, I don't want this baby, I don't want this daughter, I don't want this Turner syndrome, I don't want to have a baby with Klinefelter. We say no. Sex chromosomal abnormality, the screening and diagnosis to go for abortion is not ethical, is not legal. We should finalize the pregnancy because the IQ is normal. I am not the owner of this baby, so I should decide for her or why should decide for him. No, you are not the owner. You should take care of this baby and you go further. The lymphedema can be seen even in the higher age. The web neck can be seen clearly even in the higher age. 99% of them are aborted, only 1% of them alive, but hopefully you will see during your practice the Turner syndrome patient. Close the Turner, we will go for the only monosomy viable would be Turner syndrome. All the other monosomy would be aborted spontaneously. Look at the Klinefelter. It is in one in 1,000. Turner 1 in 4,000. Here is 1 in 1,000, which means 4 times more in male than in the female. They are tall. They have gynecomastia, means the breast is quite big. Also, there is no testis when you go to check the testis. Hypogonadism, long leg, they are thin. In Down syndrome, they are obese. In Klinefelter, they are thin. They are not obese. Also, underdeveloped secondary sex characteristic. When you see the voice of the boy, seems to be a lady voice. Also, they don't have beards. Okay? They are usually infertile, but we usually go for biopsy of testis. Maybe we can find 1 or 2 sperm, try to help them.